Alrighty. Hello, everyone. Thank you for being here. Hope you're enjoying the summer. First of all, let's give a shout out to the Collab Lab. I believe the current cohort is in session, and the Collab Lab is run by volunteers. We support early engineers to gain practical experience with a team of engineers. Um, Great. So let's give I'm pretty excited for today's call with Peter, and let me do a short introduction of him. Peter, I'm gonna try your last name, okay? Let me know if I'm doing that right. Peter Mbanugo?
Yeah, that's
No?
better.
That's better?
You did well.
Okay, cool, cool. Thank you. Thank you so much.
I've heard worse.
How do you say that yourself then?
Mbanugo with an
Mbanugo.
accent. Yeah,
Okay. So M is kind of like a silent.
yeah.
Okay, okay. Cool. Thank you. Peter is a software engineer with over a decade of experience building products, contributing to open source, and launching his own SaaS company. Welcome, Peter. I'm going to hand it over to you so you can share your slides.
Yeah. Hi, everyone. It's a pleasure to be here with the Collab Lab. Doing my first tech talk with them, but I've been a mentor twice on the Collab Lab. It's painful to see it go away after this year. I know Andrew and the rest of the team put a lot of effort. But I'm looking forward to sharing some knowledge around durable execution. And I will start also share slides. Oh, do you see my screen?
Yes.
Yeah, cool. Thanks. Also, welcome once again. As you first said, um, I've been working on my SaaS project for like a year now, at the most recent one. And you can check them out at flycd.dev or v.host. And today I'm here to talk about durable execution with Temporal, a way to build reliable systems for different programming language. And to start with, we are going to talk through it, looking at an example from an e-commerce store. Let's say you have uh, a process order, maybe business flow or logic, and implemented in the code. Ideally, how we go about designing the system architecture. On the high level, you can have just a monolithic system with functions where they can call other functions within the same process or make inter-service communication uh, external external systems. For example, we can say we have four functions within this process order flow that would check for fraud, prepare shipment, charge customer, and then the final process should the order and updates the state in the database to say that the order has been shipped or maybe the order has been received by the customer. And each of those different flows would talk to maybe external or internal microservice or some other functions within the system. Maybe also have their own separate database for each of those systems. And this is how ideally we tend to design system. But in an ideal world, when we tend to have most larger scale, let's say, for example, during the Black Friday sales, you need a way to be able to scale applications. So you can no longer wait for all those processes or checks to complete before the user gets a response from the web app or the mobile app. And this is where we tend to add other components to the system to be able to make it a reliable or scalable system. So we add things like queues, message queues, or event-driven systems like Kafka. And other databases, maybe things like timers or cron jobs, where maybe, for example, for the shipping service, maybe you try to run it once from the queuing service, and then there's a failure in being able to ship this product. Maybe it's out of stock, and you want to run some cron jobs later, or you have some checks, let's say calling the inventory service fails, and you can have an internal retry logic to check again when this happens. So we introduce all this mechanism like queues and retries to be able to do like asynchronous processing of the user's order, which means they don't have to we don't have to complete the whole order flow in a single request. Now they are dispatched into a series of actions or events. And why this looks ideal in the real world and works in some cases, reality tends to be different, because in reality now with all this added components in the system, we have a lot of moving parts in our software architecture, so many points of failure. For example, maybe just when the user needs to process, when the user comes to process the order, there could be a network failure communicating with the queue service, or maybe the payment service is overloaded and down, and we need a way to be able to retry also, or later, or also maybe this process order function crashes. We need to be able to continue running the request or the process whenever the system is back online. And all this is what leads to what we try to solve in our application. And those extra components we added, and the different failure modes that could happen in the application affects both the developer and the product. From the developer perspective, it reduces productivity, because now we have increased complexity in the application. Adding moving from a system that have just a single process function where you just call functions and execute functions and you're done. Now, when you add queues, there are different components. You have to add them to the system. Maybe you have to install things like Docker and run extra Dockers from developers' laptop to be able to have them run the application from end to end, or providing staging environment. All those adds complexity to the developer's productivity, which also reduces the feature, how much time you can create new features, uh, because sometimes the system is also hard to debug. When I don't know if anyone on the call has worked with Kafka or some other distributed system, you can tell how hard it is sometimes to be able to reproduce some certain uh, request or activity, uh, to be able to mirror that exactly how the customer sees it, because this system are quite different, and different factors can introduce different kinds of bug. And this is where durable execution, what durable execution tries to solve by removing the need for you as a developer or software team, removing the need for you to create and manage your own queues or timers, or manage your own Kafka or RabbitMQ stores, where you have to configure the topics and how you want to manage your dead letter queues, or the backbone of your retry logic, or for this asynchronous process, managing the state of where's my order currently. Is it on the payment processing step, or is it about to be shipped? With the durable execution system, it tries to give you a similar workflow to build the system, unlike other ways that people have tried to solve it in the past. The problem is not a new problem. It's been existing since for many years, as people try to move to durable execution. people try to move to distributed system. We've had this issue, and continue with that as an example. How does durable execution work, or what is it? So we have this Python program as an example of the process order, and we will walk through it to see how durable execution system will help us run this function or code reliably. So let's say you have this process already running, and you get a request from the customer. You run the function. We'll go through the steps. So the check fraud function executes without a problem. You get a response back. You move to the next step to prepare the shipment, and you try it executes without a problem. Comes back successfully. We move to the next step to charge customer. The charge request is sent, but somehow maybe the server is down or there's an error in the server, and then our process crashes halfway during the processing of the function. So which means the processing of this request has been halted. And what we can do typically is to restart the server, the application, and then with durable execution, when you restart the server, it tries to look at what processes or functions that were running before the application crashed, and runs them again following the same process. And when it runs them through, it skips all the previous functions or steps where that has been executed successfully, and stops at the last place that it encountered error, or the last function that was being processed before the server crashed. And all this happened, all this process of skipping and knowing how to um, rehydrate your function execution happens behind the scenes for you. You don't need to code how the failure scenario will be resolved, or checking for what the state was previously, because everything is managed by the durable execution system. And so it continues from this step, charge customers, and then processes the shipment, and you have a successful uh, function, or successful processing of the customer's order in this case. And unlike a system without durable execution, in most cases, you have to intervene in the process and maybe run some reconciliation scripts or extra process to be able to get your system back on track when such kind of failures happen. But with durable execution, everything is managed within a single process. The state tracking, and knowing what events to call within the system is handled by the system. So durable execution in this case is an abstraction that allows us to capture the state of our system, understand it in the context of that particular end-to-end workflow. And this changes how we program distributed system, because we move away from the mindset of trying to think about queues and topics and producers and consumers, and just program it like we program a regular function. But behind the scenes, the system would be able to deal with queues and states. And this is where Temporal comes in. So Temporal is one of the durable execution products, or right, not just a product, but rather an open source platform that tries to solve this problem. It expands on the concept and delivers a model that changes the way we build such application by taking this baseline concept of durable execution and building valuable abstraction on top of it. And these are some of the capabilities of Temporal. So durable execution is the concept, and Temporal is the tool or platform that tries to solve this problem or implement this durable execution. There are other in today's world, there are other types of durable execution tools. A few of them are open source, many of them are paid products, but Temporal is open source, and it has a few different parts. We have the server parts, we have the workers, but also apart from being an open source platform that you can install and run yourself, there's also a company or product behind it, which is also apparently called Temporal, and it it is different from any other durable execution system or similar product that tries to solve this idea of running business processes reliably. If you work on AWS, you might have heard of step functions. So step function is very similar to durable execution, but it still applies the concept of workflow, which has been how people try to solve this problem in the past. People doing workflow orchestration systems like step functions or previously simple web workflow on AWS as well. And also people are trying to solve it using business process managers. And this current evolution is people solving it as durable execution concept and trying to take it further. But moving away from the old pattern where people define workflows in with some proprietary UI logic where you do drag and drop. I think that's how step functions work. I haven't used it personally, but this is how durable execution and Temporal differs from those kind of systems. And it gives you some different capabilities like scheduling, being able to run schedule things in the future, like current jobs, or let's say in this example, if you try to ship the product but there's nothing in stock, you could delay the shipping and maybe retry again in a few days or weeks. The state of the application is being saved for you behind the scenes, and you can query the Temporal backend to tell you what stage in your workflow you're currently running. It automatically retries failed functions, like you saw in the example previously. When the process crashes here or there's an issue with the charge order function, it will know how to retry, run the retry for this function, and when it gets a result, the state of it is preserved. Also, the language support, no longer proprietary design language for workflows. You can program workflows in your own programming languages like Go, .NET, or TypeScript for people that uses TypeScript, and so many other capabilities for Temporal. And while I've shown you typically how this works on the durable execution system, within Temporal, there are a few concepts that makes this work. At the base level for Temporal, you defining this process order will be something we call a workflow. And the workflow encapsulates all the business logic from end to end. You just define it as a regular function. You don't need to think about topics or channels to send a message. And then you have within a workflow, you have activities. Activities, each of this function that processes your request, like the check fraud, charging customers card. Activities are the kind of function that when they fail, it can be retried. So they are automatically retried, but you can configure how many retries you want an activity to have. And when you have your workflow and your activity programmed with the Temporal SDK, you can deploy your application as you would do it normally, whichever workflow you use, maybe using AWS or things like Render, wherever you deploy your application. At the moment, Temporal doesn't support serverless applications because they expect you to have, for this application to run, they are running, you configure what they, within the Temporal primitive, they call a worker. So the worker listens for requests to run a particular workflow and runs the request within the worker. And the temporal service is the one responsible for communicating with the worker, knowing, checking if a particular worker is free and sending it some work to do, like a workflow to run or an activity to process. And this temporal service or server, you can self-host on your own system because it's all open source, or you can use the temporal cloud version. And this is the services, the backend that has all this complex logic, like behind the scene has the queues, things to run and manage your timers, the systems to retry your activities or workflow when they fail, and also preserving the application state. So each time you call a function or an activity, the return value is saved within the state in Temporal so that when your function comes is re-executed, it checks the state and knows where in the workflow it should continue. And yeah, all of this is scalable, whether you run it with the Temporal Cloud or you run it as your own self-host service. Before I continue, any question on what I just showed, or do you prefer to ask questions in the end? Okay. So temporal can be used for many different workflows, as long as I would say you have a complicated system that could have different points of failure, and you want to be able to retry those logic or retry those functions. There are so many examples for people using it today for different workflows. I think some popular ones are people implementing CI/CD workflow. I know this product on I think flight control, where you can deploy your JavaScript application on AWS. They provide some kind of like a Vercel alternative. I think they implement their CI/CD workflow using Temporal. Stripe uses it. If you order like order management or food delivery apps, used a lot also in banking space. And then this concept of trying to build reliable system or durable system is not something new. It's been existent over the years, and people have tried to solve it different ways, like I mentioned, like with the business process manager. You'll find a lot of similarities. The guys that started this Tempora as a product have experience trying to solve this problem. They both worked at AWS, Sam and Max. And over the years, you can see from this diagram how they've tried to solve it by implementing like a simple queue service at AWS, evolving to simple workflow service, and then going on to work separately at for Microsoft with the Azure Durable Functions and Cadence project. So Cadence is, I think, is the evolution. It's how Tempora came to be. So given how successful it was at Uber, they both, I think, started working on Tempora with some new learning. And at the moment, they believe they found the right blend of developer productivity and ease of use for durable execution. And they decided to start their own company. And today, Tempora is being used in production by a lot of different companies, from Stripe, HashiCorp, Visa, Netflix, as much as you see the big names here, I think there's also a lot of smaller companies using it to solve the problem, either self-hosted or running Temporal on cloud. And that is all for now. I don't have any demo to show at the moment because I have a few glitch with it. I'm not sure if it was my dependencies, but there's example online where you can learn more about it. So there's learn.temporal.io, which if you scan this QR code, you will be able to get, or I can also share a different screen. Either using the QR code I shared earlier or working with this. They have examples for you to try, as well as I think on GitHub, they have examples. If you use TypeScript or, or whatever SDK you have, they have examples where you can try and run the application, see how it works. But on a high level, uh, we can quickly look at how one of the examples looks here. Try to find the example for maybe I'm in the wrong repo, but I would share the link later. But the Slang.Tempora has a lot of example for different programming language based on they have courses, but they also have example application that you can try in Go, TypeScript, and you can simply walk through the example and run it yourself. And that's it. Thank you. Any questions for me to answer?
Thank you, Peter.
Thank you, Peter. Very
Thanks.
nice presentation. Not a question. Well, maybe I mean, you are a developer, right? So
Yes.
your impressions using Temporal as simply, is it developer friendly? What do you think about that?
Yes, it's very developer friendly. It's quite easy to set up and use. So you have you can run the temporal service on your own, like during development. So you have the temporal CLI, which allows you not just to call the temporal cloud, but also to run a local server backed by SQLite, and which will allow you to communicate with your application. And you can use the SDKs. They have SDKs in Go, JavaScript, PHP.NET. I'm not sure if they have on Rust, so they have for many other languages. I can see if I would find my own repo online with an example that I have. I could show you an example of how a workflow looks like. Let's see. So this is one of my products, which is no longer functional at the moment. And I have this worker. Yeah. So this has different folders, and I have these activities here that so this calls the job API to run. And this is the workflow. Let me see if oh no, I'm in the wrong branch, I think. It does. Yeah, so looking at this example, I have what the code tries to do is to run like some kind of Lambda. The way Lambda works, where there's a request coming in for your application, then it starts like a server or starts running your Lambda function based on that request. So what this service does is user gives it a set of functions, like a function file to run in JavaScript. And then when there's a request for it, not really a request, but they set up a timer for a job to do. And when there's time to run the application, it calls those workflow, and the workflow goes through different processes like creating the machine and deleting the machine. So we see how this workflow, for example, says run scheduled function. It takes a couple of parameters, and then one of the first steps it does is to create the machine using the right parameter. So this create machine we defined here. So this create machine we defined here, which basically calls an API to create machine on fly.io. And
Yeah.
we also have other functions that
Yeah.
does
So the create machine would be the activity or the step.
Yes. Yeah, the step of the activity. So in there, create a machine saves the variable of the response for the activity within machine. And then this handler is more like a way to be able to notify this workflow when it's executed that the machine either died or the job is finished. And then here it runs like a risk or a condition to either wait for 10 minutes for the job to finish. So either you wait for the job to finish successfully before it continues, or after 10 minutes, if the job isn't finished, it would delete the machine. So based on this condition, if the job timed out after 10 minutes, it comes here and then we run another activity to delete the machine on fly.io. If not, the process continues and is marked as completed, and then other parts of the system would continue. So here you will see like how we can use the Temporal SDK here to create a workflow and define an activity is just your function. Then you will wrap it within this what they call this proxy activities here. So this proxy activity is what turns it to an activity that the Temporal SDK can understand, thereby knowing, okay, when there's a failure, retry this. And we can set different retry attempts. So for this function, I'm setting it to retry only once. For this one, I'm setting it to retry 10 times, but with an interval of 2 minutes. So you can configure how much retries. If you don't configure that, I think you should retry till infinity, or you manually stop it from the temporal UI.
Yeah.
Yeah, and on
So
the servers, sorry, your question?
you know this is the case of TypeScript, because in TypeScript the way the activities are defined is because of this typo, I guess. So in every different SDK there will be different ways to characterize your code, to say these are the activities, these are the workflows, right?
Yes.
Hmm.
It depends on they try to match it to the programming pattern in that language, because people in JavaScript program slightly different from people programming Go, so they
Yeah,
will
that
help to
makes a
create
lot of sense.
semantics. Yeah, but
Hmm.
still there will be some kind of wrapper that it will be able to take your function and run it within a kind of uh, context, I would say, to be able to preserve state for those functions. If you put a regular function within the workflow here, it will just treat as a regular function. It won't be able to retrieve. But I'm not sure how they do it within other programming languages. Maybe they are able to, maybe for example with .NET, maybe they can use the reflection API and be able to intercept the code that way. But here you can have all the just one line of activity and define it. I just do this here because I want each of those activity to have different retry logics.
Yeah, this my question was more because I have a background in BPMN. I've been a consultant of BPMN technology like for years. And now I
Okay.
switched to another job where they do everything very like low level. They really like to do the things their own and all with code. They don't like these boxes and arrows connecting things. They don't like to be constrained. So my question, if it was developer friendly, is that I like the the simplicity of processes. Like you can see steps, you can see how the things evolve. This is a very good
Yeah.
thing about processes, but it's true that you lose a little bit the power of using your own language, of using TypeScript, Java, anything. So
Yeah.
yeah, so for me, Temporal looks very nice in that sense, that can combine like both things together, like robust
Yes.
processes and the same time a lot of freedom and options to to model to write your own business logic. So yeah,
Yeah.
looks very good.
Yeah, I think it fits perfectly because the concept has been, people have tried to solve it. I know last month I met someone that they have their own internal workflow, not product, but they build their own workflow system where you have to go through similar thing like this, but in their own way. And
Yeah.
you this one they have experience building all the system, and they try to find a better model for it. And
Mm-hmm.
Temporal just gives you with the programming language for the developer, no need to learn something different.
Mm-hmm.
And um, also the states, like you don't have to manage the states for yourself. Temporal automatically manages that. You can even have, like, if you have a failure in production, there's a way you can download the JSON file and then you can run it through like VS Code or your debugger and
Mm-hmm.
debug through that failed workflow and see exactly what happened
Yeah,
within it. So maybe
that's
give
super
it a try
powerful.
with whatever programming language you like. I think they have different courses. They have courses in TypeScript and Go at the moment. I'm not sure. And so
Yeah.
yeah, they have Go, Java, Python, and TypeScript. So maybe something will be there for you to try.
Mm-hmm. Yeah, sounds very promising. Let's see. if we can have at least some proof of concept to develop this,
Yeah.
because at the same time in my company now we have this map that you presented in one of the slides that was super complex with rapid MQs, with many moving parts. We have that picture. We have exactly that.
Yeah, it's usually a nightmare,
Right.
when you have to debug those things. It's so hard.
It's super difficult. It's super difficult. And slow.
Yeah,
And it's very slow.
yeah. Give it a try. If you have any questions, I mean, you can either join the Temporal Slack, but I'm also on the Collab Lab channel and Slack, so you can DM me there as well if you want to.
Thank you.
Yeah, you're welcome.
That's a great question, Jorge. Great timing too, right? Perfect
Yeah.
timing.
Yeah, I guess.
Any question from you, Natasha? Do you okay there?
Yeah, I can ask. How does temporal handle failures and retries?
So for each execution of the activities, it would record the state. So all this communicates over RPC or gRPC to the temporal service, which knows how to it tells it, okay, this function just ran. So over there you have this. I couldn't show it today, but from the temporal server, the temporal UI, when a workflow starts, it records the sequence of the activity, like an activity started, an activity finished, and each of those tells the service when an activity failed or not, and when it failed, the worker knows how to retry it, and then behind the scenes, it knows how to rerun the function, because that's why you wrap them within like an extra proxy activities, and all those will try to retry it, checking also from the server for the configured, or rather the worker for the configured retry attempts. Does that answer your question?
Yeah, that's
Any other question?
No? Any other questions?
I'm good.
Cool.
I'm grateful.
Yeah, thank you,
I'm
Peter.
glad.
Peter, I know like we have like a few resources you want to send, so let me know when you're ready to just give it to me and then I'll send to the group.
I can just pass it along now. So
Okay.
lend.temporal.io, put it on the chat. The sample repo I showed a bit earlier. If anyone just wants to look at a working example with the CI/CD, or the rather creating functions dynamically. I can't remember the TypeScript SDK example repo. Somehow I thought it was supposed to be also in this org, but I couldn't find it. So maybe from lend.temporal, you'll be able to link through different resources. But I think that's a good starter.
Mm-hmm. Cool, cool, cool. No more questions?
Nope.
Okay.
Good.
Thank you for being here. I know you mentioned it's a holiday, so thank you for Jorge. Enjoy the rest
No,
of your
it's
day.
for me it's a holiday nice activity to attend to these kind of talks. That's very nice.
Yeah. And I'm glad you can make it. I know usually the timing doesn't work for you. So,
No, this
yeah,
time it's totally fine. Yeah.
yeah. Cool. Thank you
Mhm.
all. Thank you, Peter. And
Thank you.
we'll see you next month.
See you.
Thank you.
Bye.
Bye.
Bye.